Okay, I think I'll go ahead and get started. So, hi, my name is Sydney, and today I'm going to be talking about vegetation health decline in the Gaza Strip. Before we get started, I just wanted to quickly introduce myself. So, I'm an undergraduate student at UNC Chapel Hill. So, I'll be graduating in May with a degree in environmental science and a minor in GIS. And so this project started as a quick assignment that I did in my intro to remote sensing class. My professor asked us to go into Google Earth Engine anywhere in the world and look at change over time. And so I looked at the Gaza Strip, and the results were quite shocking to me. So that kind of inspired me to push forward with this project, and that's what I'm going to be sharing with you all today. So, what is the Gaza Strip? The Gaza Strip is a Palestinian territory that is bordered by Israel and Egypt. And so, looking at this map, the Palestinian territories on the right, the larger territory is known as the West Bank, and the smaller strip on the left by the Mediterranean Sea is known as the Gaza Strip. And the Gaza Strip is quite small. It's only about 25 miles long, but it is very densely populated as it has a population of around 2.3 million people. And the Gaza Strip has been the focal point of the Israeli-Palestinian conflict since around the mid-1900s. And this conflict is very complex, so I could probably spend this entire session trying to explain it. So I will do my best to try and sum it up. And so this figure here shows how the territory has changed over time. So starting around World War II, there were a lot of Jews who began settling in the region to seek asylum, and many of them also came with hopes of beginning a Jewish state. And so as more and more Jews settled in the region, tensions began to rise, and so that is what inspired the UN to create the Partition Plan of 1947, which splits the territory into areas for Israel and areas for Palestine. However, after this, war followed, which resulted in Israel taking more land than what the partition had allotted. And so throughout time, Israel began occupying more and more of the Palestinian territory. However, in 2007, in the Gaza Strip, Hamas took control, which is a militant group and a designated terrorist organization by many nations. And so on October 7th, 2023, this conflict escalated when Hamas launched an attack on Israel, killing around 1,200 people and taking over 240 hostages. And in retaliation, Israel declared war and followed with an intense military response and enforced a total blockade on the Gaza Strip. And so within that first year of the war, the Palestinian Health Ministry reported around 42,000 Gazan deaths. I believe the figure today is closer to around 48,000 deaths. But along with this, there was significant damage to critical infrastructure, including agricultural lands. And these agricultural lands were vital for food security, especially since the Gaza Strip was under a total blockade. So the United Nations Food and Agriculture Organization conducted an agriculture damage assessment, and they looked through around the first year of the war, and what they found was that prior to the war, 42% of Gaza's land was used as cropland. However, by September 2024, an estimated 67.9% of this agricultural land had been damaged. And so that was by warfare practices such as bombing, military vehicles plowing over the land, and also to a certain degree, a lack of maintenance. And so this study used a lot of very high resolution satellite data sets and some pretty intense calculations. So for my project, I was curious if I could find a similar pattern by using lower resolution satellite data, open access data, and simpler calculations. So my first objective was to quantify and visualize vegetation changes in the Gaza Strip throughout the first year of the Israel-Hamas war. Then I wanted to compare the vegetation changes inside the Gaza Strip to those in the surrounding areas. And then, as I just mentioned, I wanted to evaluate whether this lower resolution satellite imagery, open access data, and simple calculations could reveal similar patterns to the FAO study. And then finally, I wanted to develop an interactive web map so that I could share my results openly. So this project uses primarily normalized difference vegetation index to look at vegetation health. So NDVI uses a relatively simple calculation from remotely sensed data to measure vegetation health and density. And so the values are unitless, but they range from -1 to 1. So a value of +1 would indicate very dense, healthy vegetation. A value of 0 would indicate bare soil, urban areas, or any non-vegetated surface. And then a value of -1 would indicate water or clouds. So my methods, the study area was the Gaza Strip, but then I also looked at the surrounding area. So I essentially just drew a polygon around the area. So this surrounding area includes territory from Israel and Egypt. And I chose to include this surrounding area to act as sort of a control group to see if any of the vegetation changes we were detecting, if that was a regional trend or if this is something that was unique to just the Gaza Strip. The study period goes from pre-conflict, so around the onset of the war in early October 2023, to the same period 1 year later in October 2024. And so I did it in the same months so that the seasonal variation wouldn't confound the analysis. The data products that I used is I used Sentinel-2 satellite imagery. I also used Terra satellite MODIS NDVI product. And so this product has lower spatial resolution than the Sentinel-2 imagery. However, the NDVI product was more quality assured because it went through more calibration processes. So I decided to incorporate both of these satellite products into my analysis. And then I also incorporated some precipitation data and an open access Gaza boundary shape file. So now I'd like to give a little demo of my interactive web map. So it's on Google Earth Engine. Sorry if you can't see me back here. But Google Earth Engine, if you're unfamiliar with it, it is an open access, cloud-based platform that allows you to analyze very large imagery data sets. And so I created this interactive web map using the Google Earth Engine JavaScript API. And also the link to this web map is in the description on Cvent. So if you want to open it yourself, it looks better on a computer. So yeah, what you're seeing right here is the NDVI change map. But I would like to go back a little bit first to, just a true color composite image of the Gaza Strip and the surrounding area pre-conflict. So this is early October 2024. And then when you compare this to the image from 1 year later, just by looking at the true color composite image, you can see a severe reduction in greenness in the region. And if you take this slider, you can really compare how it decreases in greenness. And then to take this one step further, I created an NDVI layer. So this is pre-conflict, and the dark values indicate low NDVI, and the white values indicate high NDVI. So this is pre-conflict, and then looking post-conflict, you can see that within the Gaza Strip, it becomes a lot darker 1 year later. And again, you can take the slider and see that difference. And then to put it all together, I created an NDVI difference map. So I subtracted these two NDVI layers from each other. And here, the reddish-brown color is where NDVI decreased between 2023 and 2024, and the green color is where NDVI increased. And so as you can see throughout the Gaza Strip, there is a general trend of NDVI decrease, and then in the surrounding area, there's no trend one way or another, but most of what we're seeing here is just typical crop rotation practices. In the bottom right corner, there is a MODIS NDVI time series animation throughout the first year of the war. And most of what you can see from this animation is just the seasonal trends in NDVI. And then the last component of my map is that you can click on any pixel in the image, and it'll generate a time series plot of NDVI in that exact spot. So the time series plot goes from October 2021 all the way up until February 2025. And so you can see in this spot, there was a pretty average trend of seasonality for NDVI, and then right around that first year of the war, there was a significant drop in NDVI. And you can click on any other pixels, and it'll generate the same type of time series plot. And you can also open them in a new window to get a more detailed view of the plot. So now I'd like to get more into the statistical analyses that I did. So this is a time series plot of average NDVI in the Gaza Strip ranging from October 2021 up until February 2025. And so what you can see is that the minimum average NDVI from the first year of the war, is noticeably lower than in previous years. And then I did the same thing, but looking at median NDVI within the Gaza Strip. And as you can see, it is the same trend of a decrease in NDVI in that first year of the war. So these are histograms showing pixel counts from the NDVI change image. So negative values indicate pixels that had a decrease of NDVI from 2023 to 2024, and then the positive values indicate an increase in NDVI. The histogram on the left is only looking at pixels from within the Gaza Strip, and as you can see, there were many more pixels that had a decrease in NDVI, and when you compare that to the pixels on the right, which are only looking at the surrounding area, it's a much more symmetrical distribution, indicating that there was no trend one way or the other, and that NDVI increase and decrease was much more balanced. And to take this another step further, looking at just the Gaza Strip, 78% of the NDVI change pixels measured a decrease in NDVI. And of those pixels, the mean NDVI decrease was 0.998. And when you compare that to the surrounding area, 73% of the NDVI change pixels measured a decrease in NDVI, but of those pixels, the average decrease was only 0.329. And so what we can gather from this is that the magnitude of NDVI decrease was greater in the Gaza Strip than in the surrounding area. So I wanted to see if this was statistically significant, so I conducted a Wilcoxon rank sum test. And so I did this by comparing a random sample of 2,000 pixels from within the Gaza Strip to a random sample of 2,000 NDVI change pixels from just the surrounding area. And by doing this, I got an extremely low p-value, which allowed me to conclude that the NDVI change pixels in the Gaza Strip were significantly different than in the surrounding area. So the next thing I looked at was precipitation. So I wanted to look at precipitation to make sure there wasn't any sort of climate anomaly going on that may have been the reason for a vegetation decline in the region. Unfortunately, I could not find precipitation data from within the Gaza Strip, so I did find some precipitation data from Ben Gurion Airport in Tel Aviv, Israel, which is about 44 miles north of the Gaza Strip. So not exactly close enough to the Gaza Strip, but it would still give us an idea of what the regional precipitation trends looked like. And in Tel Aviv, Israel, you can see that in 2023 and 2024, the precipitation trends were relatively on par with what they looked like in previous years. So my conclusions were that vegetation health and density did decrease in the Gaza Strip during that first year of the Israel-Hamas war. I also found that the vegetation health decreased more in the Gaza Strip than in the surrounding areas, so this indicates that the warfare is likely the cause for this. And then finally, I did find that lower resolution satellite imagery, open access data, and simple NDVI calculations were able to show similar patterns of vegetation health decline in the Gaza Strip, similar to the FAO study. But I did have some limitations to this study. So first of all, I was only looking at NDVI, and NDVI captures all vegetation, not just cropland. So this may dilute the focus on agriculture and food security. Additionally, the analysis did not consider differences in land use and geographic characteristics when comparing vegetation change. So, for example, I didn't consider how within the Gaza Strip there were more dense urban areas than in the surrounding area, which was primarily agricultural land. And then finally, ground truthing data was difficult to obtain from this region, particularly during this time of war. So, for example, the precipitation data that I had to pull from Tel Aviv, Israel instead. And that concludes my presentation. I wanted to say thank you to the NCGIS conference and the UNC Geography Department for having me here. Are there any questions? Okay, no questions? Well, thank you so much.